The human hand is a remarkable feat of engineering, a marvel of biological design that has evolved over millions of years. It is a testament to the power of evolution, showcasing how natural selection has shaped its form and function to adapt to various needs and environments. With its intricate arrangement of bones, joints, muscles, and nerves, the hand, along with the wrist that supports it, allows for an astonishing range of motion and dexterity. This complex structure enables us to perform a wide array of tasks with precision and strength. We use our hands for everything from the most delicate tasks like threading a needle or typing on a keyboard to the most powerful actions such as lifting heavy objects or gripping tools. Writing, painting, playing music, using tools, lifting heavy objects. These activities highlight the versatility and adaptability of our hands and wrists. All these activities rely on the remarkable capabilities of our hands and wrists, which work in harmony to execute both simple and complex movements. Understanding the anatomy and biomechanics of these structures allows us to appreciate their complexity and marvel at their function. The coordination between bones, muscles, and nerves is essential for the fluidity and precision of hand movements. The wrist acts as a bridge between the forearm and the hand, facilitating the transfer of forces and enabling a wide range of movements. It provides stability and flexibility, allowing us to position our hands accurately and maintain control during various activities. The hand, in turn, is comprised of numerous bones, joints, and muscles, each contributing to its overall function and dexterity. This complex interplay allows for the intricate movements that we often take for granted, enabling us to interact with our environment in countless ways. From the simplest gestures to the most skilled tasks, our hands and wrists are truly extraordinary. The skeletal framework of the wrist and hand is a symphony of small bones working together to provide structure and support. At the heart of the wrist are 8 small, irregularly shaped bones known as carpals. These carpal bones are arranged in 2 rows, forming a compact unit that articulates with the radius and ulnar bones of the forearm. Distal to the carpals lie the metacarpals. These 5 long bones form the framework of the palm. Each metacarpal bone corresponds to one of the 5 fingers. Finally, we have the phalanges, the bones of the fingers. Each finger, with the exception of the thumb, has 3 phalanges, proximal, middle, and distal. The thumb, in contrast, has only 2, proximal and distal. The bones of the hand and wrist are connected by a complex and intricate network of joints. These joints are not only numerous but also highly specialized to perform a variety of functions. These joints are essential for movement, allowing us to perform everyday tasks with ease and precision. From typing on a keyboard to playing a musical instrument, the range of motion provided by these joints is crucial. The wrist joint itself is formed by the articulation of the radius and ulnar bones of the forearm with the carpal bones. This complex structure allows for a wide range of movements, making the wrist one of the most flexible joints in the body. This joint allows for flexion, extension, adduction, and abduction of the hand. Flexion and extension enable us to bend and straighten our wrists, while adduction and abduction allow us to move our hands side to side. Moving distally, we encounter the carpometacarpal CMC joints. These joints play a pivotal role in the overall functionality of the hand. These joints connect the carpal bones to the metacarpal bones, forming a crucial link between the wrist and the fingers. This connection is vital for the transmission of forces and movements from the wrist to the fingers. The CMC joint of the thumb, in particular, is a saddle joint that allows for a wide range of motion, including opposition, a unique movement that allows the thumb to touch the tips of the other fingers. This capability is essential for grasping and manipulating objects with precision. This opposition movement is crucial for precision grip, enabling us to hold and manipulate small objects with great accuracy. Without this movement, tasks such as writing or buttoning a shirt would be significantly more challenging. The remaining CMC joints allow for less movement, providing stability for gripping. This stability is essential for performing tasks that require a firm and steady grip, such as lifting heavy objects or using tools. Finally, the metacarpophalangeal (MCP) and interphalangeal (IP) joints connect the metacarpals to the phalanges and the phalanges to each other, respectively. These joints are crucial for the dexterity and functionality of the fingers. These joints enable the flexion and extension of the fingers, essential for gripping and manipulating objects. The ability to flex and extend our fingers allows us to perform a wide range of activities, from simple tasks like holding a cup to complex actions like playing a piano. Powering the grip muscles of the hand and wrist. Muscles provide the power for movement. The muscles that control the hand and wrist can be divided into two groups: extrinsic and intrinsic. Extrinsic muscles, as their name suggests, are located in the forearm. Their tendons extend into the hand where they exert their actions. These extrinsic muscles are responsible for the gross movements of the hand and wrist, such as flexion, extension, adduction, and abduction. Intrinsic muscles, on the other hand, are located within the hand itself. They're responsible for the finer movements of the fingers, such as those involved in writing, typing, or playing a musical instrument. These muscles allow for precise control of finger movements. The conduits of control nerves of the hand and wrist. These intricate networks are essential for the complex and precise movements we perform daily. Nerves are the communication pathways of the body. They are responsible for transmitting signals that control both voluntary and involuntary actions. They carry signals from the brain to the muscles, telling them to contract, and from the sensory receptors in the skin back to the brain, providing information about touch, temperature, and pain. This bidirectional communication is crucial for our interaction with the environment. The three main nerves that innervate the hand and wrist are the radial nerve, the median nerve, and the ulnar nerve. Each of these nerves has a specific role and pathway, ensuring that different parts of the hand and wrist function seamlessly. The radial nerve supplies the muscles on the back of the forearm and hand, enabling extension of the wrist and fingers. This nerve is crucial for actions such as lifting objects and extending the hand. The median nerve innervates most of the muscles on the front of the forearm and hand, facilitating flexion of the wrist and fingers as well as movements of the thumb. It plays a vital role in gripping and pinching actions. The ulnar nerve supplies the muscles on the medial side of the forearm and hand, controlling movements of the little finger and ring finger. This nerve is essential for fine motor skills and intricate hand movements. These nerves work in concert to provide both motor and sensory innervation to the hand and wrist. The coordination between these nerves ensures that we can perform a wide range of activities, from typing on a keyboard to playing a musical instrument with precision and ease.